Hi guys, so today we're talking about graphing in slope-intercept form. So slope-intercept form in a linear equation looks like this: y equals mx plus b. M here represents the slope, and b here is the y-intercept. And again, the y-intercept is where the graph touches the y-axis. And so the reason why this is called slope-intercept form is because it gives us the slope and the intercept. Right? It can also be written in function notation. So instead of y, it would be f of x. So f of x, again, it means y. And then again, m here is your slope, and b is your y-intercept. So how do we graph in slope-intercept form? So step one, we plot our first point using b, which again is our y-intercept. Then all we need is a second point, and all we need to do is connect the dots. So we plot our second point by using our slope, rise over run. Our numerator, the number on top, we're going to either count up or down depending on the sign. So if our slope is positive, we're going to go up. If the slope is negative, we're going to go down. Okay? And then the denominator, we're going to count to the right. Okay? It's easier that way, where you only think up or down and always to the right. Okay? After that, you plot that point and you connect the dots to draw the line. Okay? So let's get started. So here we're going to graph y equals 3/4 x minus 2. So my slope here is 3/4. My y-intercept, my b here is -2. And so this is 0, -2. So start by plotting my y-intercept. Then I'm going to use my slope to get my next point. Okay, so since this is positive, I'm going to move up 3 and then always to the right. Okay. So from this point, I'm going to go up 3, 1, 2, 3, and to the right 4. 1, 2, 3, 4. Okay. And then I'm going to connect the dots. The reason why when I connect it sometimes I go a lot slower is because I want to make sure that I'm consistently going up 3, right 4, right? So that way it's the most accurate graph as possible, and we'll see why when we get to systems of equations, right? So for sometimes I even keep going, I go up 3, right 4, and then all the way until the end. Okay? So here is the next one. Okay? So here my slope is -3. And we know that if it's not a fraction, it can be written as a fraction by going over 1. Okay. My y-intercept here, my b is 4, so it's 0, 4. I'm going to start by graphing my y-intercept at 0, 4. And then I'm going to use my slope to graph the next point. Okay? So since this is negative, I'm going to go down 3 and then always to the right, so right 1. Okay? So down 3, 1, 2, 3, right 1. Okay? And then just to make it consistent, I can keep doing it. Down 3, 1, 2, 3, right 1. Down 3, 1, 2, 3, right 1. Down 3, 1, 2, 3, right 1. Right? The reason why is because sometimes when we get further and further from our first 2 points, our ruler, it might make it not as accurate. So that's why I just keep going down 3, right 1 through the whole thing. And there you go. Okay. Sometimes, though, the equation is not in slope-intercept form. For example, here, 3x minus 4y equals 20. This is in standard form, right? We might recognize it from when we graphed using intercepts, and you might be like, Miss Ng, I can just graph it using intercepts, right? But sometimes, depending on the coefficients for x and y, right, the intercept might be a fraction. For example, here, let me use another color. For example, here, my x-intercept, right, if I were to solve for my x-intercept like I did before, 3x minus 4, plug in 0 for y and solve, right? This gives me 3x equals 20, and when I divide by 3, this gives me 20 thirds, or 6 2/3. Right, and even though this is accurate, this is the x-intercept, when I'm graphing it, it doesn't give me the most accurate line because of the graph on the paper. Okay? So as a result, right, when this is the case, right, instead of graphing it using intercepts, what I'm going to do is I'm going to change it to slope-intercept form. And we do this by solving for y. So let's get started. So here I'm going to rewrite this in slope-intercept form. I'm going to identify the slope and the y-intercept, and then I'm going to graph. Okay? So I want y by itself, so I need to get rid of this 3x and this negative 4. Because this is a positive 3x, I'm going to move it to the other side by subtracting 3x. 3x minus 3x is 0. 0 minus 4y is negative 4y. Okay. And then just so it looks like mx plus b, I'm going to actually put this first, so negative 3x. And since this is a positive 20, it will be plus 20. You cannot combine these. These are not like terms. Then I'm going to get rid of this negative 4, right? Since I'm changing it into slope-intercept form, I solve for y. I'm going to get rid of this times negative 4 by dividing by negative 4. Negative 4 divided by negative 4 is 1, so 1y. Negative 3 over negative 4, that becomes now positive, so positive 3/4 x. And then 20 divided by negative 4 is negative 5. So here, my slope is 3/4. My y-intercept is negative 5, which is 0, negative 5. Right? And so now I'm going to graph. So starting with my y-intercept at 0, negative 5. Then my slope here is 3/4. It is positive, so I'm going to go up 3 and then always to the right 4. So I'm going to go up 3, 1, 2, 3, right 4, 1, 2, 3, 4. And then just to keep it consistent, I'm going to keep going 1, 2, 3, 1, 2, 3, 4. Right? You technically only need 2 points, but when we're graphing, when we're writing, solving our systems of equations, it'll help to have the most accurate graph. So I'm going to connect, making sure that the whole time I'm going up 3, and then connect. And then arrows at the end, because it actually keeps going on in both directions forever. Okay. So we're going to do one more here. On rare occasions, we have to make modifications when counting the slope. When counting the slope hits the edge of the graph. Okay. So here, y equals 5/2 x plus 7. So first, my slope here is 5/2. My y-intercept here is 7. So b equals 7. So 0, 7. Okay. So I'm going to start by graphing that y-intercept at 0, 7. Okay. Then, using my slope, I'm going to get my next point. Right? So since this is positive, I'm going to go up 5 and then to the right 2. right? When I start counting 1, 2, 3, however, I can't go up 5. There's no more in the graph. It won't be accurate. So when this happens, what we're going to do is we're going to do the complete opposite of this. So instead of going up 5, we're going to go down 5. And instead of going right 2, we're going to go left 2. And the reason why is because down is negative, left is negative, negative over a negative still gives us that positive, so it still works. So I'm going to go down 5, 1, 2, 3, 4, 5, and then left 2, 1, 2. Right? And then to keep it consistent, I'm going to keep going 1, 2, 3, 4, 5, left 2. 1, 2, 3, 4, 5, left 2. Okay? And I'm going to connect the dots. All right, so really you only need 2 points, but just so that way it stays consistent throughout the whole graph and it's as accurate as I can possibly make it. That's why I do the other points as well. So that's it for today. Have a great rest of the day. Bye, guys.